We are talking about the tech behind user-friendly wizards, or so-called user flows, something like you see here, but of course in modern. Something like a ClickFunnels or a user journey, something like this here. And let me give you a demo of something we just built. This is a wizard, and every wizard is basically attached to a customer, and these customers flow through the wizard. You're going to see this in a bit. I'm just showing you here the list of customers and every customer is in a certain step of that journey. So if you click on this here, we see this is on step number 5, seed selection, and we would now be able to go through from one to the other. What is cool about this is that this here has the URL. It's local on my machine right now, but this is the step 1 here. And once we go to the step 2, we're able to enter data, and then we advance through the wizard or through the user flow. And there are a couple of things I want to talk about the architecture here, because if you apply these principles, then your users will be able to leave the wizard anytime and get back to it. We're going to see this in a bit. Work with multiple developers on it, so you can offload the workload and not interfere with each other. You can test this independently and reuse different models. I did this in Ruby on Rails, but there's only minimal Ruby on Rails code. I'm going to explain most of it on my iPad in a bit. And yeah, you can save parts. So we use a certain technology which is a bit newer than this old Ajax technology. We have something called Hotwire, but there are frameworks in PHP and in the Phoenix framework and so on that all do the same thing. We're going to talk about that. What we need is also a strong authorization framework and good validations. Okay, let's look again what we want to achieve. Important for us is that we have like a lot of forms, and we want to cut them into different parts. So we want to make sure that we can enter data here, and then on every step enter more and more and more data. And we don't let the user go to the next step if the previous step was not completed. So let's say if we put something in here where we're missing the first name, so we save this, we get an error and we cannot advance to the next step because there is an error. So we need to fix that first. Till Carlos, save. That's one of the principles. Okay, so how do we do this? What's the basic concept of this? And this is pseudocode. I try to write it in a very generic way. The way we have this, so this is a so-called flight offer we have. The main model does not have any data attributes. We move all the data attributes into these other models. And I'm going to show this real quick here. Okay, so what you see here is the flight, which is the main model that we want to look at. This is the one that flows through the user flow. So this is the model that we create when we enter the user flow. This is the thing that is attached to the customer, and when you click on it, you would be able to open this right here. And this is all going to be the same model, which is here, the flight. And as you go through it, let's say we go to customer, now we have the address, which is here, and we have some ID card, yeah. So here put in your password. So we have those now, this is there, and we set them to the flight record. And only later we set the seed selection. The seed selection is on the step number 5. Once we get there, we're gonna attach this as well. And the good thing that in this case is that we can always save the records, and we can always validate. So let's say, as you saw here before, once you validate this, you cannot go to step number 2. So the validation of a record is being done by, let's say, if this validates, it would validate this here. And if it's red, you cannot advance, then it will stay on the maximum step 1 in this case. The next principle that really works for us here is saving something outside the current page. So when you see here, this is the context of the flight. So there's a flight controller and there's an MVP pattern below it. But when we save the ID number, we are not saving into the flight, we're saving into the ID card model with an ID card MVC. Let me quickly show you how this looks like on an MVC. I just drew the MVCs for all these different models. Basically, when we are here in this step of the view of the flight, we would now save, let's say, the ID card, and we would now hit the view of the ID card and the controller of the ID card and the model, of course, as well. So let's look at this again. This whole view here is the flight view, but this view here is just the form, is parts of the view of the ID card. So this basically hooks into the main thing. So it's gonna look a bit weird, but I'm gonna try to make this here. So this goes in here. Okay, so now the view gets included in here. So this is now the ID card. Once we save it, this ID card will save into the controller, save the model, and then the controller will catch that view back and send the view back here into this. So that means this whole page here will be reloaded with our technology here, in our case Ruby on Rails, Hotwire, but there's other Livewire, Laravel, or LiveView from Phoenix in the Phoenix framework. And I think there are many others like this out there. For Django, we have the same thing. But the basic idea is, if we do it like that, we only need to code the form once. We don't have duplicate code, and we can also keep all the calculation that needs to happen here in our controller of the ID card. And I love this method because it will make the flight controller much leaner. This is something how it looks like in Ruby on Rails code, at least, because here this is the address controller that gets hit when we are actually saving the address from here. And the update method is just very simple. Just find the address, and then there's something I added here, save and render. So save and render just says, basically does two things: checks the validity, checks the authorization, and then saves. We're going to talk about the authorization in a bit, because that is super important and a core principle that we apply here. But before we do, we'll talk about the advanced steps without calculation. This is important because basically what we want to do here is, let's say someone does not have the ID card put in, but we need it. We cannot go into the seat selection. And the way we do this is we calculate a maximum step. And you saw this here earlier. Step number 5 is in here. And we will be able to go here. But let's say if we would not have the ID card set, then the code looks like this. We calculate the maximum possible step where we say the ID card, okay, this is pseudocode. I didn't put the ID card in here, but let's say here the customer data is not set, so we don't have the customer data here. If the customer data is not there, then the maximum we can go is step number 2. We cannot advance to step number 5, and so all these links would not appear. This is how we can make sure that the people don't advance to a step that would break a calculation. And now the very important thing we want to talk about is authorization. And this is something I need to sketch again, because again, for other frameworks it might be different, but in Ruby on Rails there is something that's called, it's a package that previously it was called Pundit. It still exists, but now someone made something really nice. It's called the, let me see if I can find it. It's called the action policy. The action policy is a package that does a lot of stuff, but the basic idea is that you write policies. And the policy always is the model name plus policy, and then you can say, can you index it? Can you show the list? Can you update it? And what's great about this is that in our schema here, the person being able to edit the flight, edit the container model for the wizard, for the user flow, and say that that's the owner. So on the data model, it looks like this. The flight here is bound to a person who's managing the flight. Let's say the travel agent, right? The travel agent owns the flight. And now the address has a policy. And the address policy, we know that the address belongs to the flight here. So the address policy has a specific code that checks if the address belongs to a flight that belongs to the travel agent. So in the policy, we have the user and the record, the user and address. And now we can easily just say address dot the flight dot owner equals user. And if we have that, then we can say, okay, this is checked, this is done. This person here can now edit the address. So in that way, we keep the concerns totally separated. We don't need to check any kind of authorization in the flight model. We have it very nicely reduced to the address namespace. So the address takes care of MVC, but also the policy. And we have this everywhere here. All these models have policies, and of course also the flight has a policy. That's an abstract overview of how you can code a wizard. I hope this was somewhat understandable. If it was not, please send me an email or comment on this YouTube video. I'm happy to also show you code if you want, but this was the high-level overview, and this took me 2 days to refactor, and now it works really well. And I hope you enjoy it too. If you have more questions on abstract stuff about software development, that video might be for you.